Let's take a look at a slightly more challenging interest rate problem. Here we have a person, her name's Maggie, and it says she invests $6,900 for 1 year between two savings accounts. We don't know how much she invested in each of the accounts, but together she invested $6,900. One of the accounts earns 7% interest, and the other account earns 3% interest. And they ask us, they say, how much did she invest in each account if she earned a total of $335 in interest between both of the accounts? So this is a very classic problem. We see this type of problem all the time. And for whatever reason, this type of problem gives students a lot of trouble. So we'll try to make this very clear as far as how we solve this type of problem. So the main thing I would encourage you to do when you have an interest rate problem like this, where you have multiple accounts or multiple people or things like that, is to use a chart. Charts are extremely helpful for problems like this. So in your chart, you'll have a row for each of the accounts. So they'll have one row for the 7% account and another row for the 3% account. And then this helps us visually see things like the principal and the interest rate and the time invested and the interest coming from each of these accounts. And so hopefully we'll be able to write an equation based off of this stuff. So let's look at the 7% account first. I want to first of all find the principal that was invested in the 7% account. Well, you read through the problem and they don't tell us. They tell us that she invests $6,900 total, but that's not exactly how much is just in the 7% account. So if you don't know a quantity, you have to label it by a variable. So we'll call this amount X. So she invests X dollars in the 7% account. So I don't know how much that is. Now it's tempting to now say for the 3% account, well, since I don't know how much she invested there either, then I'll have to call that like Y or something as another variable. But actually that's not the best idea. There's something better that we can say. See, remember, we know she invested a total of $6,900. So the amount invested in the 3% account will be the $6,900 minus however much was in the other account, the 7% account. So we'll put 6,900 minus X, which is minus how much she invested in the 7% account. So just for easy math, I'm not saying these are the actual numbers, but let's just pretend in the 7% account, maybe she invested $900. Well, then that means in the 3% account, it must be 6,900 minus that $900, which would be just 6,000. Now, I'm not saying those are the correct numbers. I'm just saying that's why you can put $6,900 minus X, minus the amount from the 7% account. And the math will work out a lot easier when it's done like this because you have less variables. You don't have X's and Y's. The interest rate's pretty obvious. The 7% account will be 0.07 expressed as a decimal. Anytime you're using percentages in math problems, when you're doing the math, you really need to express them as decimals, not percentages. The 3% account will be 0.03%, obviously. The time will be 1 year, if I remember correctly. It's invested for 1 year. And obviously that would be the same for both accounts. So what would be the interest coming out of the 7% account and the interest coming out of the 3% account? The 7% account, you'd have P times R times T. That's the formula for interest. Interest equals principal times rate times time. So we'll multiply these quantities and we'll have 0.07x. And in the 3% account, we'll have 0.03 times $6,900 minus X. All right, so there's our chart. It's filled out, but now what do we do? Where do we go from here? Well, let's look back and see if we haven't used anything in the problem and see what we're looking for. The end question said, how much did she invest in each account if she earned a total of $335 in interest from both accounts? So when we look at this here, one thing that catches my eye is the fact that we know the interest coming from account A and account B, the 7% account and the 3% account. And it says total, we had, what was it? $335 in interest. So isn't it fair to say that 0.07x plus 0.03 times 6,900 minus x, this is the interest from account A, this is the interest from account B, if we're calling this A and B. Total, this would equal, what was it? I believe it was $335. Okay, and there we have it. We have an equation that represents the math problem. So we can solve this for x. So we'll do things that we know we should do, like distribute any constants through a binomial like this, combine like terms, etc., etc. So let's do that. We'd have, let's see, 0.07x plus, we need to take 0.03 times 6,900. We'll take 0.03 times 6,900. We'd get 207 minus 0.03 times x equals 335. All right, we have a couple like terms here. 0.07 minus 0.03 is 0.04x, and then we'll subtract the 207 to the right hand side since it's being added on the left hand side, and we would get 128 on the right hand side. We'll divide both sides by 0.04. 128 divided by 0.04, and we'll get 3,200. So this is $3,200. But what does x represent? What is x? Look back at your table. X was the principal. That was the amount that we invested in the 7% account. So that's good to know. And from there, we can also determine how much was invested in the 3% account as well. So in the 7% account, it was $3,200, and in the 3% account, don't forget, it was $6,900 minus X, or minus $3,200, which would be $3,700. Okay, if you wanted to take the time to go back and check this, you could do a couple things. First of all, notice that her total investment is $6,900 if you add the two quantities together. And then you could also go through the math and then verify that the interest that she really earned from both accounts really was $335. So that's how we solve these very typical, these very common interest rate problems where you have investments in two accounts. You make a chart. You have multiple rows representing each of the accounts. You write your principal and your rate and your time and your interest, etc. And then you use the information provided in the word problem to write an equation that you can solve that'll tell you how much was invested in each of the accounts.